In the last stream, we were working on setting up the beginnings of our integrated dynamics storage and crafting system. We got a storage terminal, we got a crafting job terminal, and we set up our first crafting interface with a crafting table to allow us to auto-craft whatever recipes we teach to the crafting interface via these variable cards. Now, one problem that we did run into in the last stream is that because of the way this mod pack is set up and because of the fact that certain recipes are locked behind quest unlocks, the integrated dynamics system isn't able to craft certain items using a regular crafting table. Basically, when you're looking at a recipe, if the recipe has any text here where it says stage transcond item 1, if it has text there, then the integrated dynamics system isn't going to be able to craft it using a regular crafting table. This kind of recipe can be auto-crafted, but we have to either use these auto workbenches, which are pretty cheap to make and are also free from a power standpoint, but they're fairly slow and they're a little tedious to set up because you can't shift-click in the recipe. So if I wanted to teach one of these how to make the item conduits, I'd have to go into my system, get the steel, get the glass, and then manually place it in to set the crafting recipe. For a recipe as simple as item conduits, that's completely fine. That's not really a big deal. But as we start looking at more and more advanced recipes, that is where the sequential fabricator could be the better choice, because the sequential fabricator can also craft the gated recipes, much like the auto workbench, but it's faster. It does use power, and you can shift-click in the recipe that you want to teach. So here I could just shift-click in the recipe for conduits, and then click the set recipe tick box, and it would save it. So for recipes like this with the crafting interface, where it would be a little bit tedious to go and craft two crafting tables, go and get an input variable transformer and an output variable transformer and a block of crystallized mineral and then 4 iron ingots, and then manually place them each into their correct respective slots inside of the auto workbench, that's where I think something like the sequential fabricator is going to be the better choice. Basically though, between streams, chat, I have done a little bit of reorganizing here. I've moved the cable that houses our storage terminal to the center of this room, and I've also crafted 2 more storage terminals. This wasn't really necessary, but I think it just looks nicer, and it means that whatever way we walk into the room, we can just walk right up and be straight away into the crafting terminal, and we can request whatever it is that we want to request. I've also gone and set up even more crafting tables here. Right now, only this one has a crafting interface, but all of these crafting tables can be hooked up with a crafting interface, and that's going to allow us to auto-craft just a ton of recipes. Like well over 100 recipes are going to be available to us using all of these crafting tables. And then over here, I've put down a bunch of auto workbenches. Again, right now, only these 2 have crafting interfaces. The downside, of course, again, is that these can only do 1 recipe at a time, whereas each crafting table here can do 9 recipes at a time. And so what I've done over here, I've taught this auto workbench how to make the output variable transformer. I've taught this one how to make the input variable transformer. And over here, we, of course, have this one on the sequential fabricator, which we set up in the last episode, and this can make the crafting interface. And so I think now we are almost there on being able to request crafting interfaces. It shows as being doable. The only thing that we don't have automated is slime balls. We've automated regular pistons. We could very easily automate the production of sticky pistons if we can automate the production of slime balls. And as we saw in the last episode, the best way to do that, I think, is going to be through deep mob learning, because 1 pristine zombie matter can be turned into 16 slime balls, and so I think getting unlimited slime balls shouldn't be too hard for us. Chat does make a good point that I completely forgot about, actually, and that is that, unlike the sequential fabricators here, over here you can't extract automatically from the auto workbench, which definitely is not ideal. I do wonder how it works if you put an item extractor onto the auto workbench. And by that I mean like an importer. This guy right here. If we put an item importer onto the side of this, I wonder if that kind of talks to the crafting interface and registers the craft as being complete. Let me see if that works real quick. The item importer, super easy stuff. If you've ever played with something like refined storage, it kind of works in the same way. We can use it to import items from the auto workbench around into our system here. So all we have to do here is at the top, input all items. We can just put a variable card in here, and that is going to be set to true. And so I'm hopeful that that will import whatever is made here. We can test it by quickly requesting a batch of those output variable transformers. We do already have 4, but if I go ahead and request another 1 and say craft, it should send all of the required items over and into here, and then hopefully, if it all works well, we should get them sent to the output. And we can see up here, recipe is not allowed. Okay, so I think this does work. We had a little bit of a weird bug, I think, that just happened there. For whatever reason, just now, I tried to request this output transformer, and it kept saying recipe not available, and we were trying other stuff to see if it would work. I've temporarily thrown the recipe for item conduits in here, although I guess, to be honest, I could probably leave this here, because being able to request these is maybe useful, but after a lot of bug testing, all that we had to do was just break and replace the workbench. So if you're having issues with this, just break and replace the workbench. Over here, if I do this, we should see that gets imported. Fantastic. And so let me see if I can show you this one more time. So we've got a ton of these output variable transformers now. That is not a problem. We're going to need a lot of them going forward. But if we try this again, next, and craft, we should see all of the items sent to here. We did. The output variable transformer somewhat slowly gets crafted. Again, the trade-off here is that these workbenches are cheaper to make, and then once the transformer is made, it then gets imported via the importer here. That does then complete the craft. You'll see there's no longer a crafting job scheduled in the job terminal, and then in here, we've got 4 output transformers. Nice. So it does indeed work, and so now I'm fairly certain that if we can automate the production of slime balls, we can fully automate the production of these crafting interfaces, which is the first thing that I'm trying to automate, because then I can just request like 32 of them and then quickly fill up all of these, sequential fabricators, auto workbenches, and crafting tables with these crafting interfaces, at which point we can then start to auto-craft a lot of stuff. Between streams, I did run an energy cable from the boiler setup round and over to these sequential fabricators. The plan in the future is to have these going all the way up to the ceiling. Same's true with the auto workbenches there. I do plan on filling that floor in momentarily. The other thing that I've done between streams is I've kind of done a bit of work on this section of the base. I've not really done too much in terms of changing how the deep mob learning setup works. I am thinking, though, that I might move these to the center at some point. I think I might look a bit nicer. But basically, I've just put down a lot of conduit facades to try and cover up the mess of conduits that we had around before. And I've also changed a little bit of some stuff. If I get my wrench here and we shift scroll to item conduits, we can see that here, actually if I go to energy conduits, we can see that I've moved the energy conduits. These used to be at the back, like this, but I've moved them to the side and hid them in these marble blocks, just so that I could move these logic cables further up, so that they're now not in the way. And I've also gone ahead and just built all of the loot fabricators and simulation chambers that I think we're going to need. So we've got the one for glowstone that we set up in the last episode, but we now also have 4 more of them around the outside here, which is perfect because today I want to start by getting a few more of these up and running. The first one I want to do is, of course, the zombie data model. That is going to allow us to automate the slime balls. And then on top of that, I also want to get the simulation chamber set up for the Enderman data model as well, because once we have Enderman, Witch, and Ghast all running at the same time, we should then be able to automate the production of utility research, which is then going to unlock the next era of the pack for us. So, back in here, we are looking for the zombie data model, which might be in the top bottom left. There it is, perfect. So I'll run that through real quick. Once that's done, we'll do the same thing for the Enderman data model, and then I think all of these pipes are basically already configured. I think everything here is set to like extract, always active, and then insert on these two here and here. I guess you don't really want these to insert too quickly, otherwise they're probably going to end up getting a pristine matter. But let's do this. Let's try and find the Enderman data model, which is here. While we wait for that to finish up, back over on this side, let's do something like this. You'll see it's already receiving the polymer clay. Again, it's all hooked up at the top. You'll see there's a lot of conduits in the roof here, distributing power and items to where they need to go. This should start doing its job. Eventually, we'll need to set this up to work with the slime balls. Down here, we've already got the item interface ready on the drawer, so that is all good to go. And over here, the Enderman data model is ready to go as well. And so, boom, that's also going to start producing the Ender Pearls for us. And yeah, I think we should be pretty much good to go here. Let's make sure that we go ahead and set this to Overworldian Matter. And I will grab the draw key just to make sure all of this stuff is locked. We'll do that. I'm also fairly certain that the Enderman data model produces extraterrestrial matter, so we'll take that out and throw that in over here as well. That way we can make sure that all of these are set to extract, always active, and all of these are set to insert. And of course, much like we've been doing, many times before, we'll go ahead and get 2 void upgrades here to make sure that those never cause the system to clog up. Boom, and boom. Over here, we have our first pristine matters. We can go ahead and set that to slime. And again, if all of this is set up correctly, which it is fantastic, we can then go ahead and lock that door. And now if we check the system, we should have access to those slime balls. Cool. Over here, eventually we'll get a pristine matter for the Enderman. And when that comes through, we can obviously set that to Ender Pearls. I don't think it's going to make anything else, although it's quite possible it might make Chorus Fruit, potentially. Nope, it just makes Ender Pearls, so that's all we're going to get from this, but that's perfect, because that is all that we need to get. And there we go. Boom, Ender Pearls are coming in. As soon as they get made and set down, we'll go ahead and lock that. Fantastic. And now, if we head back, we should be able to request quite a few of these crafting interfaces. So let's actually put this system to the test. Can I make 10 of these? The answer is no, because it doesn't know the input variable transformer, which I did have taught over here, and should still be taught over there. What is the problem with the input variable transformer? It doesn't have the sticky pistons. Oh, of course, and it doesn't have the variable cards. That is fine. There are 2 things we need to fix there. The first is that I need to put a recipe for variable cards into this crafting table. That is fine. Let me grab all of the variable cards that we do have out of the system, and let's do something like this, and we're going to use a variable card to teach a variable card how to make variable cards. Fantastic. We'll throw that in over here. That should work. It does. Although, yeah, though this is fine. You'll see there's no stage at the top, so this is all good to go. That's fantastic. And then we do need to actually teach the interface over here how to make sticky pistons as well, because right now the system does know how to make regular pistons. It just doesn't know how to make sticky pistons. And so boom, and boom, that's all good to go. And of course, the final piece of the puzzle is going to be getting another importer. One thing we could probably do here, if we wanted to, there's a few options. We could put an item importer onto every single one of these workbenches, but if we wanted to do it in a little bit of a cheaper way, I think what we could potentially do is maybe just get some kind of chest, have all of the items output to that chest, and then import from that chest. So, for example, if we were to do this, and we were to put the item importer onto the chest, so like that, we could then put the variable card in here to say import all items, and then I'm fairly certain that if we were to do this, and basically just set all of these to extract always active, that should pull any finished product out of the auto workbench, basically out of all of these workbenches, send it around into this chest, and then this chest will just pull it into the system. And of course, as per usual, if we use the conduit probe here, and make sure it's in copy mode, we can shift right click to copy, and then just right click to paste the same configuration to all of these conduits. And I think that should work. So now we've got all of that set up. Let's try that once again. If I wanted 10 of these, we've got everything to do it, craft. I think everything should kick into gear and should just start crafting. Of course, we do need to set the insert on the chest there to make sure all the items go where they need to go. So it looks like we have the same issue here that we had a second ago. Right here, it says input variable transformer, and it says recipe not allowed. So if I cancel the job, I'm not quite sure. We might just have to give up on using the workbenches, because from my testing, it seems to work quite well with the sequential fabricators, but less so with the workbenches here. I think if I break and replace this workbench, it might work. So if we put this back down like that, and then the recipe is 2 of these here and here, it's then a sticky piston in the center with, I think, 2 just mineral crystals, which are now connected, by the way. If you didn't see it earlier, we do have our little setup for making mineral. It is here. We got our fluid transposer, drying basin, intercompacting drawer, and I just threw down another one of these omnidirectional connectors with an item interface to connect that up so that everything works. But if I reset up the recipe in here, so I put the piston in the middle and I put the chunks here and here, that's showing again. Let me then try this one more time. Start and start. Is that sending the items to here? It is not. Okay, so I think that we're going to be on the same issue here. It says pending dependencies and it says recipe not allowed. So, okay, cancel all jobs. We might have to give up on the auto workbenches. Let me try fully moving these 2 recipes over to the sequential fabricators. So over here, this one is already pre-configured for the output variable transformer. So I'll put that in like this. And then on here, we'll do the input variable transformer. We'll teach that, shift right click, and we'll just put that into another crafting interface. Let me steal one of the interfaces that we have over here if we're not going to use them. There we go. And we'll throw that down right about there, like that. And then we'll put this in. So I think now this actually might work. Let me try this next and start. So now, is this working? I think all of these are set up correctly where the input and outputs are set on the back. If it says the same thing, oh no, it's doing it. It's doing it. But it's working. Look at that. Things are being crafted. I think they're just a lot faster than we can see. With the auto workbench, you can kind of catch it before it's done. But no, it is done. The 10 interfaces have been crafted. And so, yeah, it does work with the sequential fabricators. It just seems like for whatever reason, I'm not quite sure why, sometimes it works with the auto workbenches, and sometimes it doesn't. It seems somewhat random. It can do the item conduit recipe, like seemingly all the time. The input one worked a second ago when we tested it, but then we broke and replaced the output one, and then that one worked, but then it didn't initially, and then now this input one doesn't work. And so we're just going to have to retire these benches, and although the sequential fabricators are more expensive and they do require power, the trade-off there is that they are a lot faster, and the biggest benefit is that they actually work. And so I guess we'll go ahead and use these going forward. Speaking of which, let me go ahead and just throw down, I guess, all of these crafting interfaces onto the remaining sequential fabricators so we can set those up in the future. And then over here, we can, of course, do something like this to start basically unlocking all of the potential of these crafting tables. And, of course, we can request more of these and kind of add them as we go. For now, though, I think what we can pivot over to is we can take a look at setting up the next tier of research. For that, we need to get a few more metal presses, and we also need to get, I think, a few more induction smelters, because if we were to take a look at the next tier of research, that being utility research here, the utility research requires 1 lumium gear, 1 signalum gear, and 1 enderium gear. It also requires 500 redstone flux per tick and a total of 1.8 million redstone flux per utility research. So this research is going to be a lot slower than the previous research that we've been doing. The production research, for reference, only uses 240,000. So we're talking a lot more power per research. We can, of course, bring that power down by using the energy modules. The energy modules, if we have 2 of them, will reduce the power usage to 125 RF per tick, and they'll also bring the total energy usage down to 25% of 1.8 million, whatever that happens to be. So in order to make the 3 gears here, as I was saying, we're going to need more fluid transposers is what we need, because each one of these ingots can be made in the fluid transposer using a kind of base ingot and then a fluid. The fluid is what we get from our deep mob learning setup. So we need destabilized redstone, automated. We need resonant ender, automated. And we need energized glowstone, automated. Each one of these we get from each of these items. So we can turn glowstone into energized glowstone, we can turn redstone into destabilized redstone, and we can turn ender pearls into resonant ender. We just need a magma crucible and or a melter for each one. Now, the melter in the long run could be faster, because with the machines from NuclearCraft, if we were to spend quite a bit of research unlocking the NuclearCraft upgrades, you can put up to 64 speed and 64 energy upgrades into each and every NuclearCraft machine, and they work extremely fast. For the time being, I think we're going to have to stick with the Magma Crucible, just because of the fact that, for one, actually, we can't even make the melter yet, because the melter requires an unfamiliar item. I'm fairly certain that item is a plastic sheet. I think it's right here, a plastic plate, sorry. Once we have that, then we can look at making some of the machines from NuclearCraft. On top of that, I don't really want to spend that much research right now on unlocking this NuclearCraft upgrade. And so let's go ahead and see if we can't get 3 more Magma Crucibles, along with 3 fluid transposers, because we still do need to make the actual ingots themselves, the enderium, the signalum, and the lumium. And then we also do need to make 3 alloys as well. We need lead platinum alloy for the enderium. I'm going to go ahead and bookmark that. We need an ingot whose name I cannot pronounce, but we need this alloy right here for the signalum. And then for the lumium, we need this tin gold alloy. So we need 3 induction smelters, 3 fluid transposers, and 3 magma crucibles. And then after that, we either need to get 3 metal presses. Alternatively, if we look at the quest line here, after the metal press, there is the option for the compactor, and the compactor is able to make plates, and if you upgrade it with the gear working die, it can then make gears in a 1-block space without the need to take up as much space as the metal press. And so I do think that is going to be worth investing in, especially because right after that is the mega metal press. This one is very expensive and is going to require some of the utility research that we don't yet have, that we're working towards making, but the mega metal press is insanely fast and is going to be good to get at some point in the near future. For now though, if we want to get the compactor, we need 16x8 logistics, and then I think we just needed the regular version of the mechanics and the production. Fantastic. We then also need to get a bit more production for the gear working die, and I picked the wrong one here. That's fine. Let me put these back and let me take out you. We can then do this and this. And so now we can start working on making these machines. Before we do that, what I might do here is I might see if we can't get some automation going on this, because magma crucibles we need, the induction smelter we need, I'll bookmark that, the compactor now we need, again, ideally 3 of those to make 3 lots of gears, and then the final machine was the fluid transposer. A lot of these crafts are going to be easier if we can teach our system how to make things like the redstone reception coil, how to make things like the machine frame, and of course, in an ideal situation here, we would also teach our sequential fabricators how to make sequential fabricators, because in doing so, that then allows us to very quickly expand this setup. So, if we want to teach you how to make the sequential fabricator, this is a gated recipe, and so that is going to have to be done via a sequential fabricator. That is completely fine. Let's do something like that, and then let's put that into one of our free crafting interfaces and make sure that is set to the sequential fabricator. Crafting table's already done. Redstone reception coils are not gated, and so can just be taught to a regular crafting table. We'll use this bottom one over here. We'll work our way up as we go. I don't think that it gets slower. If you put like too many recipes in one, I think it's the same speed no matter what, so that's fine. Copper gears are an interesting one. For the time being, I'm going to teach it this recipe, which is not particularly copper efficient. However, I think what we're probably going to do in the future is, much like we did in the last episode where we tried to automate with the redstone furnace, and this did work, by the way, we can do the same thing with a compactor. Once we get a compactor down, we could have like a general purpose compactor that is used for making all of our gears, and so we can have that set up to make the gears more efficiently using the gear working die. For the time being, though, we don't have a compactor ready to go, and so I'm just going to go ahead and teach it the slightly less efficient recipe, which shouldn't really be a huge deal, simply due to the fact that we've got almost 20,000 copper in our system, and we've got a ton more copper ore, like, backed up in the rail network as well, so that is completely fine. The machine frame recipe, thankfully, isn't a gated recipe, and so much like all the other ones here, can just be taught to a regular crafting table. That is completely fine. As I mentioned in the last episode, I think one thing we are going to have to do here is we're going to have to figure out how we're going to get these steel mechanical components auto-crafted, because again, it might be worth setting up some compactors here, because the recipe for steel plates, 1 steel to 1 steel plate, is quite good. The recipe here of 3 steel ingots to 2 steel plates is less good. And so it might not be a terrible idea to get going with all of this. And then I think we are going to want to set up this automated engineer's workbench. And so, like we did last episode, if we grab the manual, I think what I might do real quick is see about crafting up the items required to make the automated workbench. Those being steel scaffolding, treated wooden slabs, a redstone engineering block, a light engineering block, heavy engineering block, and conveyor belt, all stuff we made before. I think we'll look at setting this up, throwing it down somewhere, and then hooking it up to our auto-crafting system so that we can auto-craft things like the steel mechanical component more efficiently. Alright, so I've got all of the blocks required here. Unfortunately, we don't have a blueprint for this. Like, we don't have just a capsule that we can put down, which means we are going to have to put this down row by row. Thankfully, that shouldn't be too difficult. So I'm just taking a look here to where, like, the direction I want to put this down. I think I'm going to put it down kind of like, maybe like this, because the blue here is where the input goes in. And then the orange, I think, is where power goes, and then this is the redstone pot. So I'm going to put it down facing this way, because I want this side here as close to this integrated dynamics cable that we have on the right as possible. So we'll go ahead and hit pause, and then we'll go down to the bottom level like this. So we want our heavy engineering block in the bottom left corner. So we're going to put that down right about here. And then we've got like a zigzag of steel scaffolding like that. And then if my memory serves me right, it looks something like this. I think that's correct. It is indeed. We want it like this. And then the second level has 2 more light engineering blocks on top of the last one, another heavy engineering block on top of the last one, and then just belts and slabs. That is completely fine. We do this, we do this, we do this, and then I don't know how much it matters the way these go. I think, though, it was like this. And if it's done correctly, we should be able to grab our engineer's hammer, and much like the other multi-blocks from immersive engineering, those being the blast furnace and the coke oven, we can then right-click this onto here. You right-click on this side, and boom, it forms the multi-block. You do have to right-click in a specific place for it to work, but once it's all up and running, we just now need to hook this up to power at the top, which I don't know how much power this uses, but I'm hopeful that we can just kind of tap into our pre-existing LV wire system. So if I do something like this, I don't know where our nearest cable is. I guess it's right there. Do I have a spare post? I do not. That is not surprising. We've not made these in a little while. And of course, as per usual, the bricks, for whatever reason, do not shift click in. That's fine. Let's put this right about here. And then let's see if we can't get this connected. So we'll do you, we will do you, and then of course we'll do, hopefully, you. Perfect. All right, that should give this power. It does indeed. I'm assuming it doesn't use that much, I hope. And so now, we need to actually craft with this. The automated engineer's workbench. I have not used this before. I don't know if we need to give this a blueprint. We totally do. That's completely fine. And then we just select what we want it to make. So the annoying thing is that we need to have one of these per recipe that we want to automate. But I think that's kind of fine. We're going to automate the steel mechanical components. And for that, we need 1 copper and 2 steel plates, right? And if I put both of these into here, like that, if that recipe is correct, which I thought it was, let me check that again. People are saying I need to give it a redstone signal. That's fine. Let's take a lever and let's do that. And yeah, that works. Cool. So you see the items go across. There's a pretty cool animation here. I do quite like the look of this. And it would be cool to do more auto crafting with these, but they're just so much more expensive to make than, you know, like a sequential fabricator, and they take up so much more space. So this does work. And so now I think what we should be able to do is if we take another one of those crafting interfaces, which we are going to have to go and request, I think that shouldn't be a problem. Let me see about crafting, like, let's say another 10 of these. For that, we're missing iron. Hold on, are we out of iron? We are out of iron. That is not an ideal situation. I assume the reason for that, oh, it's a slag problem. It's a slag problem. It's an odd slag problem? I think all of our slag has managed to get clogged up either in this induction smelter or in this induction smelter. I think we can kind of prevent this happening in the future by just adding more slag to the system. I do have 93 rich slag in my inventory. I want to make sure that we have at least 1, 2, 3, like 4 stacks of slag in the system. If we do that, I'm hopeful that we're kind of never going to not have enough slag, because there should always be enough slag to go around. So let's get this back online. Let's make sure that we prioritize the iron here. Hopefully that's going to come back somewhat quickly, although I do imagine that a lot of our machinery here is going to start to use that slag, which is not ideal. But once we've got a little bit more iron, we can make another crafting interface. And I think it should just be a case of hooking that up to this here. Now, this did kind of throw the item off the edge. I believe, if I'm not mistaken, that if I put a chest on the end right here, it should put whatever item is crafted into that chest. And much like we've been doing inside, we should then be able to make an importer. And at this point, we can go and just steal the importer that we made earlier, because right now we are not using this setup at all. So I'm just going to steal that real quick, and I'm going to go place that onto the chest. So I'll put that down, let's say right about here, and then we'll connect that up to our main line, like so. And once that's done, we can, of course, throw in our import all items card. If you wanted to, by the way, you can filter with this. There's import item and import items. So if you wanted to filter one item, you could take the portable programmer, throw in your card, select item from the list. If you don't see item, you can just type in item, click it, and then you could filter what it is. So if I only wanted to import sticky pistons, I could put that in there and then take this out. And then if I were to put this card into this slot, this is now only going to import sticky pistons. If you want to import like a list of items, you can put your card back in, you can click on list, and then you can go to items, this one here, and then you can just add items. So you can click add, and you can add really as many items as you want to that list. and it will only import the items on that list. So there's a bunch of cool stuff that you can do to really kind of highly customize these. For us, for now, it doesn't matter. We can just import anything that is inside of this chest. And so once again, if we give this a quick test run while we wait for our iron to come back in, we'll put in 2 steel plates and 1 copper ingot. Let's go. Boom, boom. That should get sent out. Fantastic. Should get crafted. Beautiful. And then should get sent around into the chest. And as soon as it goes in the chest, it should get imported back to the system. Nice. Okay, cool. So that is going to work as soon as we get some iron back online. And it looks like the iron is getting there. So once again, let me try requesting maybe just 1 crafting terminal this time. We don't necessarily need 10 of them. We can then snag that. And then over here, let's just drop that down on one of the inputs. Either this one or this one would work. I'm going to do it right about here. Drop this down like so. And now if we go and teach the recipe for the steel mechanical component, I'm fairly certain that this should work. If I do this, we do want to get rid of the engineer's blueprint there. We don't want the system thinking it has to send that because it doesn't. We just want it to send 2 steel plates and 1 copper, and that's going to work. So let's give this a try, shall we? If we head back to our interface, we have some steel plates and we have some copper. If I request a steel mechanical component, we've got 48. I would like 2 more. Craft. That should send the items over. They should be processing through that auto workbench, slowly but surely. They should end up in the chest, and then once they get imported, they should eventually come back through to here. There's number 49, and I'm sure that any second now, number 50 will make its way in as well. And so, yeah, that system does indeed work. The only kind of final step for this now is for us to automate the production of steel plates, and for that, I think we are going to have to make at least 1 compactor. If we're going to make 1 compactor, I think we should make 2 compactors because we want to have 1 compactor for making plates and 1 compactor for making gears because, again, if we're going to set it up, we might as well get the more efficient copper recipe going as well. And so let me quickly craft up 2 compactors here. I don't think these are too difficult to make, assuming that we have what it takes to make a few more machine frames, which we might have. Yeah, we've got some more machine casing here, and so I'm fairly certain that if we do 1, and I think this will work for 2. It totally does. And then I think after that, do we have everything? We totally do. 1 and 2. Nice. We do need a gear working die for 1 of these. The gear working die is 4 iron gears and 1 redstone servo. Now that we have iron coming in again, that's not going to be a problem. And then we kind of just have to decide where we're going to put these machines. And given that this whole setup here doesn't work, I think what I'm going to do is kind of tear down this whole section here and start using this area for automated machine crafting. Okay, so I've got down these 2 compactors and I've run some energy cable over to here. I've done the same thing that I've done with the sequential fabricators, so we have space for more machines here, and of course more machines going up the walls as we progress forward. The cool thing about the compactor, though, is that unlike the sequential fabricator, we can teach 1 compactor multiple recipes. So if we set the back here to input and output on both of these, we can then throw down our crafting interfaces, boom and boom. We can, of course, make sure that those are connected up, like so. And these right now have nothing in them. That's perfect. But essentially, what we should be able to do, if we go and take the copper gear card out of there, and we re-encode this with the cheaper recipe. So copper gear. Let me teach it this recipe here. 2 copper, 1 copper gear. Encode. We should now be able to put this into whichever compactor we decide to give the gear working die to. We'll do it to this one. The gear working die goes into the augment slot, like so, and now this is able to make gears. By default, the compactor will just make plates, and so if you were to put 2 copper in here, it would just make a plate. However, with the gear working die, it can make gears, and so in here, if we add the gear recipe, I'm pretty sure that should now just work. Let's give it a try. Copper gear. I want to make 10 of them. Next. And start. We've got 62 to begin with. We should see copper being sent over. We totally do. It does only send 1 batch at a time. I'm still not quite sure why it does that. But the good news is that because it doesn't have to have the recipe locked inside of it like the sequential fabricator does, we can add up to 9 variable cards to this crafting interface, and that gives us up to 9 recipe slots for this compactor. And of course, if we really wanted to, we could also set another side to input-output and probably just put down another crafting interface to double up on the number of recipes that we teach to any one compactor. Whether or not that's a good idea really depends on how fast we make it, but this totally works. For now, I'm going to go ahead and cancel this craft because we don't actually need all of those copper gears, but this is good. And so we can do the same thing, of course, with steel plates. If we go and find steel plates in JEI, we can click recipe, and then we can shift click in the one steel to one steel plate, stick that in over here, and now I think we should fully have the steel mechanical component automated, because we have the copper, the steel can be auto-crafted from the steel that we have available to us, and that's going to make that steel mechanical component. Then that steel mechanical component can be used in the making of the machine frame. That is the reason that we were doing all of this. I think we did teach the machine frame. We did. Perfect. So mechanical component is taught. The treated wood is not taught, and the machine casing is also not taught. Now, the trouble that we're going to run into here is kind of twofold. One, we're going to need another induction smelter to automate the production of modularium. That's fine. We can throw that induction smelter down over here somewhere, and we can teach that recipe, and that should potentially work. We could run into some issues with the whole multiple inputs thing, the fact that you have to put in both redstone and iron. That could get a little tricky. We might have to do some extra configurating to make that work. But the even trickier bit is going to be the fact that treated wood automation might be a little tricky, especially given that we don't have wood automated. And so we're getting a little derailed here. I did want to get the next tier of research up and running today, but it might not be a terrible idea for me to finally actually look at getting this wood automation going. So if I do want to get wood automation going, we need to get a Phytogenic insulator. We're adding to the list of thermal expansion machines we need, and we also need the sapling infuser. We need both of those. Those do require aluminum gears, which we can make with aluminum ingots, and the aluminum ingots we can make with glowstone, along with, I think it's a tin gold alloy. Is that what we saw earlier? It is. A tin gold alloy, you'll be surprised to hear, is an alloy between tin and gold. Please, hold the surprise. But back in here, I think it's probably about time that we set up a general purpose induction smelter for doing these kinds of crafts. For that, one more machine frame, easy enough, and then we just need to get ourselves an Invar gear. Perfect. And that should be everything, I think, for the induction smelter. Nice. So we'll throw this down, maybe like right here, and I'm going to rotate that to face away, just because that's how we've done it with all of our other machines as well. And for now, we'll just throw in you, and that should start making those tin gold gears. While we wait for that, let's make a couple of upgrade kits so that we can make those alloys just a little bit faster. This just saves us having to kind of interrupt and break our ore smelting line every time we want to make, something like modularium, which is just going to make our lives that little bit easier. Boom. Once we've got the tin gold alloy, of course, again, now we are going to have to get a fluid transposer. We do have a fluid transposer. It is over in here, right? But I think, again, trying to hijack that one is going to be tricky. Let's just go ahead and make another magma crucible and another fluid transposer. And I guess let's get like the automation for Lumium up and running. All right, so one fluid transposer and one magma crucible later. I think we're going to set the automation up for this around here, because of course my plan is going to be to just add a fourth line of researchers right here for the next tier of research. I think that's going to make the most sense. I might end up moving these compacting drawers if we need the space, because I think we might end up needing the space for a lot of this automation that we're about to set up. But let's start by just throwing down the magma crucible and the fluid transposer. Perfect. From there, we can just connect that up using the good old-fashioned LV wire connectors. At some point in the not-so-distant future, we are going to have to upgrade our power infrastructure to keep all of this stuff running. But for the time being, I think this might be fine. Let's do this and this. I guess that is too close. I wonder if I can do that and that. I totally can. It's a little bit horrendous, but it does get the job done. And so right here, if we get some glowstone, we can throw that glowstone in like that, and that's going to start to break down into energized glowstone. We want that energized glowstone to go out into the fluid transposer. And then in the fluid transposer, that is where we're going to put our tin gold alloy, which we should have a decent amount of over in here. We totally do. Nice. So let's throw a bunch of that tin gold alloy into the fluid transposer. And while that works and does its magic, we could probably do, like, what's the power usage on this? 40. We can't go over 100, which is not ideal, and it takes a while for this glowstone to melt. While we wait for that glowstone to melt, though, we do need a few other things, right? We need to get the augment here. The augment Doesn't require anything too difficult apart from the lumium gears. The same, I think, is kind of true for the Phytogenic insulator. The only thing we really don't have is the lumium gear. Everything else is pretty straightforward. And it's going to make sense, I think, for us also to get a monoculture cycle augment. This one is a little trickier. So the benefit to the monocultural cycle augment is that by default, the way this is going to work is we put a sapling into the Phytogenic insulator along with at least one phytogrow, and that produces 6 wood. Depending on the type of phytogrow you use, we are probably going to set things up with basic phytogrow. You can get rich phytogrow or even fluxed phytogrow, which is the highest tier. That does produce more wood, but essentially the way it works by default is you get a phytogrow, you put in a sapling, that turns the sapling into an oak wood and an oak sapling, but it takes the sapling out of the input slot and puts it in the output slot. So what we could do is we could set up a cycle, like a loop, that takes the sapling from the output slot and feeds it back into the input slot. But if you get the monocycle augment, you can then just put that in and it will keep the oak sapling in the input slot. And I think it will also stop it from producing more saplings, if I'm not mistaken. Non-fertilizer inputs are not consumed. Improving automation provides a minor chance to not consume fertilizer. Additional energy is required per operation. Secondary output chance is substantially reduced. So it kind of almost gets rid of the secondary oak sapling there, which would be nice for keeping the system clean. The only trouble then is that in order to make it, I do need at least one fluxed phytogrow and a signalum gear. The fluxed phytogrow should be fine, actually. I think we have what it takes to make at least one batch of rich phytogrow. We can do it with the sawdust, the rich slag, and the niter. The niter could be our limiting factor. Rich slag, of course, we could potentially steal from here. I know I just put some back in because we were having trouble, but if we leave that there for now, back over here, do we have any niter at all? We do. We've got loads of niter. We're actually backing up on niter, and we're actually backing up on irothium dust. That is almost certainly because over here we are fully backed up on ores, and so that's good for now. Obviously, we are going to hook that up as soon as we run out of our naturally occurring iron and copper ores, but that should be everything, I think, for some rich phytogrow. And then we just need to make, I think, yet another thermal expansion machine, that being the energetic infuser, in order to actually infuse this. So that just requires one more lead gear, and boom. This doesn't need to be part of our automation chain, and so for the time being, I'm going to haphazardly place it here, just so that we can do this and get our first fluxed phytogrow, which then should allow us to actually make this monocultural cycle augment. We do need signalum for that. To make that signalum, I think we will hijack once again this setup here. So in here, we've got 9 lumium ingots, which I don't think is going to be enough because we need 2 lumium gears just for the sapling infuser. So we do need to get a tiny bit more lumium. And so you know what? Let me do 1, 2, 3. We'll leave that in there, and then we'll also put a bit of glowstone in the magma crucible as well. While we wait for that to do its thing, let's go and make the signalum base alloy, which is copper and silver. That also seems very doable. Copper we have, silver we've got a little bit of. We'll throw both of those in over here. And once those are ready, we can then swap out the glowstone in the magma crucible for redstone, and we can swap out the tin gold ingots for the signalum base ingots as well. Okay, so the redstone is melting and the alloy here is ready to go. Let's take our lumium gears then and see if we can't make a Phytogenic insulator. Of course, for that, we're going to make the actual lumium ingots into lumium gears, 1, 2, and 3. That is going to get us the Phytogenic insulator. Of course, we do need another machine frame. And of course, for that, we do need more machine casing. And I'm hopeful that we do have a decent amount of modularium. We do indeed. Fantastic. And so finally, let's take 2 of you. We'll make 1 Phytogenic insulator, and we'll make 1 sapling infuser. Nice. Okay, cool. So we'll take this, and it doesn't necessarily matter too much, I don't think, where we put this. For some reason, I've got this area over here on my mind, simply because of the fact that it's kind of where all the wood stuff already is. But I think it's probably going to make more sense for us to put this somewhere else, simply due to the fact that we could do with like a better power source. So I might put it here. Again, TBD on the final resting place for this. But if we throw in the sapling infuser augment, there are 2 things that we now need to do. We need to automate the production of phytogrow, because the phytogrow is used in the production of this. I think potentially the best recipe for us here is almost certainly going to have to be this one that makes 16, right? It takes 1 slag and 1 pulverized charcoal and makes 1 niter. This should be fine. If we can take a storage interface and drop it onto this niter drawer, like that, and then connect that up, of course, to the main line up here, which we totally can because we just run this along like that, and that's going to give us access to niter, so we can now autocraft with that niter. We could then do with 2 more things. The first thing we could do with is a pulverizer. We could do with a general purpose pulverizer that we're going to use for producing the charcoal. So over here, I'm going to put that down like this, and we'll rotate it to face away, like that. Make sure the back here is set to input and output. And again, if we get another interface, we can then use that pulverizer to autocraft the pulverized charcoal. We could also do, I guess with getting 2 of these actually, I know I just requested 1, but if we request 1 more here, because we could do with also putting our redstone furnace onto the wall as well. Let's rotate you to face away, and if we connect both of these up, we'll do this and this, we can use the pulverizer to produce the pulverized charcoal, and we can use the redstone furnace to produce the actual charcoal. So if we go and get our programmer, we can then look at the recipe for charcoal, and if we go to the furnace, we can then shift-click this in, and oak wood is exactly what we want. Let's do this and this. Perfect. So now this knows how to make charcoal. We can then go and do the same thing again here. We'll put this in, go to recipe, go to pulverized charcoal, and if we go ahead and shift-click that in, we can take this card and place it in here. Cool. So what we want to do next, I guess, is also pick up this rogue interface that was on our redstone furnace previously. That is no longer needed. The final piece of the puzzle, I guess, is really just to teach one of these crafting tables how to craft the Phytogrow itself. So we'll take the card again, we'll do this, we'll type in Phytogrow, and we'll shift-click in this recipe right here. There are obviously easier recipes. I'm a little worried about this one just devouring all of the slag that we have, which would not be ideal, and this one is kind of just as difficult as this one, so I think this is the best option because it is the most efficient, and we're going to make wood as part of this endeavor anyway, so right here, that is good to go. We'll put you in like so, and then what we're going to want to do is, I think we're going to want to get an item exporter. We've made item importers so far, but we've not made item exporters. The exporter, super easy to make, and once we have it, we can then put that down, let's say for now on the top, like this. We'll set the top here to input, and if we connect that up to our integrated dynamics system, and get rid of any excess cables that I may have accidentally placed down, we should now be able to specify what we want this to export, and we're going to do it in the same way that we did earlier. So real quick, do we have any oak wood? We do. So let me see if I can actually request 16 Phytogrow. If I request 1, it should make 16. It's saying we don't have slag. We definitely do have slag. I think the trouble there is that the recipe is configured with the wrong type of slag. So let me do this. Let me type in, first of all, let me grab some slag out of the system. At least 1, and then back in the programmer, if we try and redo that recipe for Phytogrow, we should be able to shift-click to change this to match any equivalent by OR dictionary, but I think it might be easier just to do this, and then take this card out. That should now use the correct type of slag, and so let's try that one more time. Phytogrow, next, and craft. Hopefully, that is going to make all the stuff we need to make. The charcoal is being made. It should get pulverized once it's been made. And then it should get crafted together with the niter. And we should see, hopefully, any second now. Look at that. 16 Phytogrow. Nice. Cool. So we can take this. And over here, what we're going to do is we're going to open our logic programmer. We're going to put in a card. We're going to type in item. And we're going to say Phytogrow. Then we're going to take that card and we're going to put it into this exporter. So if I were to put it into export item right here, it should start exporting the Phytogrow. And it did. It took the Phytogrow instantly out of the system and placed it into the Phytogenic insulator. But we could take it one step further. If we click this little plus button here and we go all the way to the end, there is an option for craft. It says if the instance should be crafted if it is not present in the network. And we want to set this to true. Now, what it should start doing is it should start making more Phytogrow, which is what it's going to do. And it's basically going to keep crafting Phytogrow until it can no longer put any more into the Phytogenic insulator. And so right now it's going to craft more, and we should see, hopefully, look at that, boom, we got 32. It's then going to get 48 and 64. And once 64 is in, then it's going to stop making the phyto grow, at least until we need more. And then as soon as we use some, it's going to send some more out, and it's going to keep sending it out until it runs out, and the system should repeat. Now that this is taken care of, we can take a sapling, and we can place that in here. My original plan, oh, we do need water as well, actually, so I could probably do with another aqueous accumulator. My original plan, of course, was to use the monocultural cycle augment, but the Twitch chat has kind of talked me out of it, I think. If we just use a 2x1 drawer, that being a storage drawer that can hold 2 items, we might be able to automate this in a much easier fashion that leaves us room in the future for even more augments, which would be good if we need faster wood. So let's do this. We'll set the back of you to output, and we'll set the back of you to input. That's going to receive water. This is going to start doing its thing. Let's get a 2x1 drawer. I'm going to get a framed version, and of course I'm going to make it look like marble, and then we'll throw that down like here. And the idea here is if we set the bottom to output on orange, it's going to push both of those down. We can then lock this drawer like that, and the only trouble there... Oh no, actually it's completely fine. We can just change it to in and out, because then if we set it to auto input, it's going to pull the saplings. I don't know where it got a spruce. I don't know where it got 16 spruce saplings from, but it should pull a sapling out of this drawer up into the Phytogenic insulator, and then once it's done, I have no idea where it's getting 16 spruce saplings from. Does it make spruce saplings for some reason? Like, when I take that out, that works as well. If I, hold on, if I turn the bottom off, is it pulling from something else? Is there somewhere else that it's pulling those? It is pulling those from somewhere else. I'm not quite sure where it's pulling those from. Because the item, I think it's doing it from the item type here. Channel, round robin, blacklist, false. That's correct. Item transfer, exact amount. Like, I think this exporter is exporting the item. Like, I'm pretty sure if I disconnect this, that it will stop sending those. Yeah. But then if I reconnect, like if I put these saplings back in my inventory and I reconnect this cable, that's exporting spruce saplings, which is very odd because that should not be happening. This should only be exporting the item that is specified in the card. So I don't know what the problem is here, but I think what we can do to temporarily solve it is just change the top here to insert green, which is only going to insert this left slot. So now if I take that out, it can basically, this exporter can no longer export to both slots. It can only export to this first slot, which is Phytogrow. This does mean that eventually, if we do for some reason run out of Phytogrow, like the system isn't able to make any more Phytogrow again, that could be a problem. Turning off auto input might help, actually. Let me try that real quick before we commit to this. If I turn that back to blue. Interesting. Oh, okay. So I think that what might be happening there, this is already set to auto output, so we don't need auto input on. But I guess in that case, the Phytogenic insulator is pulling, like, from the exporter, and then it's just pulling from the network. It's pulling anything that it can pull. That is really interesting. So you turn this on, and it starts pulling random saplings. Okay, that's good to know, because I really did think that the filter, like, whitelist would work there. So, fair enough. I didn't know that the machines could pull from an exporter. I figured that wouldn't be the case. But anyway, this works. And so now we just need to go ahead and make sure the bottom is set to input and output, like this. And then we need to just leave it. And it should start pulling. Oh, no, but we do need auto input on, don't we? Oh, that's bad. We need auto input on because we need to be able to pull the saplings out of here. We could use an item conduit to do that, but I think the better solution is just going to be to what I was about to do, which is make this green and then turn auto input back on. At which point now it's going to pull the oak saplings that are made out of here, back up into here. It's going to use them to make more wood, send them back down. That's also going to make another sapling. It's guaranteed to make another sapling. There's a 100% chance. And so we're never going to get any more saplings. It's just going to keep using the same one over and over again. But we do now have an unlimited amount of wood. And so if we go ahead and take an item interface, we can then drop that down right about here. Connect that, of course, up to the main pipe like that. And this now works. So now we have unlimited oak wood, which is going to just keep going forever. And so now we can utilize that unlimited oak wood to produce unlimited treated wood. And for that, I think what we're going to want to do is get another sequential fabricator. And this time, I think we're going to have to unlock another piece of research that's going to allow us to craft using this sequential fabricator and fluids. So the sequential fabricator on its own can't craft with liquids. However, if we check the quest book, there is a bit of research here, which is not too expensive. It's more expensive than I'd like it to be. But what else is new? And once we have that, what we should be able to do is craft up the fluid crafting augment, which is this one here, fluid fabrication. Super easy augment to craft. And with that, you can now pump liquids into the sequential fabricator. And I'm, of course, going to pump that in via our fluid tank. So I'm thinking if we do maybe this, what we should be able to do is grab some conduits, fluid conduits ideally, from our system. I don't think 9 is quite going to be enough, but I'm fairly certain that then we can export from our tank. And I think we can pull from the bottom here. So I think we can kind of run this along, set this to extract always active. And over here, set the right-hand side to input, and then, of course, give it the fluid augment. Then it's going to start filling up, ideally, with Creosote. Yes, I had to break and replace that after I put the augment in. But you'll see that is now filling up with Creosote. And then once that's full up with Creosote, then all we need to do is, I guess, get another exporter interface, which is not that. I want another item exporter, which does require another variable card, which thankfully we can make. Let's do that. If we put that item exporter on, I was going to put it on the top, but I guess right here on the back would work to save a cable, and we can set the back there to input. This time we're going to get another card, and we're going to tell this to export planks. So we do need to teach our system how to make planks, because I think right now it only knows how to make crafting tables, bizarrely. But if we do this and type in plank, we can teach it this recipe. Drop that in here. That's our first full crafting interface. Over here, I want to teach this how to make treated wood. I'm pretty sure that what we can do here, if I get another bucket, I think I can take a bucket of creosote, I can take some oak planks out of the system, and I'm fairly certain that if I teach it the recipe like this, even without the buckets, it will pull from this tank. So if I put just some wood in here, it should then begin pulling this creosote and this wood to make the treated wood. Of course, for this to work, it does need power, and that's not going to work because of the way that that's set up. A little bit of a way you can cheese this, I think, is if you break this, connect this, and then replace this, that totally works. And you'll see this is crafting despite the fact that it doesn't have any creosote buckets, which is great. So what we want to do is we want to take our portable programmer, type in item, drop in the wooden plank, drop in a card. This card is for item conduits. We don't need it currently. And then once that's set to planks, back over in here, we can put that into export item. And once again, we can go all the way along to craft and type true. And then that should start crafting the oak planks and sending them to here. And again, we can do something like this to make sure that it doesn't send too many oak planks. And then the final step of the process is to grab yet one more drawer, place that drawer, let's say here, set this to output, auto output. That's going to put the treated wood in that drawer. We can then lock that drawer. And if we put an item interface onto this drawer as well, like that, and connect it up with our cable, we now have unlimited and automated treated wood. So now that we have treated wood automated, we're one step closer to being able to fully request these machine frames. The only thing now that we don't have automated, because we've done the steel mechanical components, we've done the treated wood, is the machine casing. So the recipe for the machine casing itself is pretty straightforward. For that, we are going to need a few more variable cards, but we do have more of those, and of course we can request them as and when we need them. The recipe for the machine casing is pretty straightforward, and we can add that to our next crafting table there. The tricky part is the modularium, because for this we need to use the induction smelter, and my concern here is that with the compactor, we can give this really as many recipes as we like, right? We've taught it how to make copper gears, but we could do the same with aluminum gears, iron gears, tin gears, lead gears, silver gears, signalum gears, enderium gears, any gear we want, right? We could put all of those recipes in here, and because the compactor can only hold one item at a time, that would be fine. However, the induction smelter is awkward because it can hold two items. And I think the trouble there is that as we get into more advanced crafting, if we try and request something that requires two different alloys, let's say we want both bronze and invar at the same time, I think it's possible that we might end up in a situation where two things end up in here that don't need to be in here. So let's say there's some gold in here because it's trying to make electrum, right? And so this is waiting for silver, but then at the same time, the system is trying to request invar. My first question is, if I were to try and put nickel in there, does the nickel go in or does it just like refuse to work? No, it totally goes in. So I could see this being the case where it's trying to do both at the same time, although that might not be a problem because of the way that the integrated dynamic system works. We've noticed so far that it only ever puts one item in at a time, and so it might actually be okay. If we do this, and we go back and we get another card here, we set this to recipe, and we set this to modularium. That's the one that we actually need right now. It's quite possible that we could just do this and this, and because it only ever does one batch at a time, this actually might just work. So we'll set the back to input and output, and I guess let's give it a go, right? Let's see, can I get some modularium? We got 9. If I wanted 10 more, start. It, I think, is only going to send one of each at a time. It is. That is pretty nifty. And it's actually kind of just like a built-in way to prevent the wrong items being sent, which is pretty cool. The only potential way this could be a problem is if it tries to send, like, I assume it doesn't. Like, I was going to say the only way it could be a problem is if we need some modularium and it decides to send 1 iron and we don't have any redstone, but my assumption would be that the integrated dynamic system is smart enough to not send anything until we have all of the items required. So, now that it's taken care of, I think we are good to go. I think we can actually finally automate these. If I wanted 20 machine frames, can I do that? I totally can. Craft. And so it should start sending modularium to that. It should start sending coal over to here. I guess we're making more Phytogenic as well. It should start sending steel to the compactor. It should start sending copper and steel over to here once we have all those steel plates. We should be making steel gears as well over and around here somewhere. There's the steel plates being made. Of course, all of these machines could do with being a lot faster, but everything does work. Like the process does work here, and now it's just a case of making things faster so we can get these machine frames in a shorter period of time. But for the most part, it looks like everything is good. Let me see though real quick if I can't get a couple of upgrades kits here, because the compactor especially is quite slow. So let's do maybe 2 of these and maybe 2 of these, and then let's do 1, 2, and I guess for now 1, 2. We can also grab some more augments as well. These are all connected up to our main power system, so these can be upgraded. The other machines that we have are not quite so fortunate. 350 is a lot of redstone flux per tick, but I think it's kind of fine. What I mean by that is that our machines outside are connected to LV wire connectors, right? These ones right here, which I think is going to be bad, right? So I think next time when we come back, we're going to work on that utility research. This is not going to be fast enough, these connectors here. So we're going to have to work on either getting the next tier of cable, or maybe just kind of getting rid of the LV or MV cables entirely and just running conduits to everything so that we can make those machines faster and actually get them to work in a reasonable amount of time. But this is all working, and hopefully we will soon start to get some machine frames. The treated wood is backing up over here. We've got almost a full draw's worth. That is perfect. People asked about a storage downgrade. We could have put a storage downgrade in here, but again, we have unlimited wood now, so I really don't think it's strictly necessary. Let me check. Oh, I guess we're just still waiting for steel plates, eh? I was gonna say let's check like what the holdup is here. We're still making the Phytogenic, which is good. Yep, it's still making the steel plates for the modularium casing there. That's all getting made. I think the way it's working here is it might be making all of the steel plates before it starts making any of the mechanical components, which is a little slow, but it's probably fine. I do wonder if there's a way we could speed this up. Oh wait, we can. Oh, but you can't go any lower. You can change the number of ticks per operation, but you can't go lower than 5. So this means that something only happens once every like quarter second, as opposed to once every tick. It's not the end of the world, and it's kind of about the same speed as the compactor here, so it's probably about as fast as we want it to go anywhere. But yeah, that is auto-crafting kind of taken care of, and hopefully we will slowly but surely gather these machine frames, and next time we can use those machine frames to craft up all of the compactors, all of the fluid transposers, and all of the magma crucibles, as well as all of the induction smelters that we're going to need to automate the signalum, the aluminum, and the enderium that we need in order to make the utility research. And then once we have that utility research, we can then start working on a bunch of other stuff. There's a couple of things here. We do want to get the tier 2 ore automation up and running, because we kind of need that in order to automate utility research. Utility research does require things like tin, things like lead, things like whatever other platinum is another one that we need for the lead platinum alloy here. So we need to get that tier 2 infinity miner online so we can get an infinite amount of those resources to keep the utility research coming in automatically. For that, we're going to have to automate the production of these mining drones so that we can keep that ore coming in as well. That's probably what we'll work on after we have the utility research. And yeah, then we can start working on oil, which is kind of the next big thing we need to work on. Oil, we can then refine it, we can get plastic, and we can use that to get into the next tier of research after utility research, and we can keep pushing forward, because I think at that point we're pretty close to the final tiers of research. Chemical is tier 5, and then after tier 5, there is just quantum. So we're almost there. We've done half of them. We've got 3 more to go. Let me go and give this one more check. How are we doing on machine frames? The answer is that we're maybe getting there. Yes, we've got a few more to craft. Job waited. Yeah, waiting for dependents to finish. I see. So it does wait for all of the dependents to finish, which is not ideal. It would be better if it could start making them before all this was done. Like, it would be faster, I should say, if it did that, but I guess at the same time, it's also more prone to things going wrong if it does that as well, which is not ideal. It looks like that might be done, though, and so we should start to see, yeah, this is working. It's making those steel mechanical components, and so, yeah, this is all good to go. One thing we could potentially do if we wanted to make things like this faster is, instead of doing what we're doing here, where we kind of just make them whenever we need them, we could put down a drawer somewhere, a storage drawer, put an exporter on that, put a storage downgrade into that drawer so it can only hold 64, and then basically just tell it to auto-craft until the drawer is full. And that way, it would kind of keep 64 of them on tap all the time, and then whenever we needed them, it would just pull them. That might be a better way of doing it. You know, we could do the same thing with steel plates and whatnot. We could all kind of just always have 64 steel plates, always have 64 steel mechanical components. Heck, always have 64 machine frames on hand ready to go. And then whenever we use one, we could have it just make another one in the background passively, so we're not like actively waiting for the recipe to come in. And yeah, I'm going to quickly finish up this floor here, because I did say that I was going to fix this before we wrap up the video. And with the floor fixed, I'm going to go ahead and wrap up this episode of Feed the Factory there.